The Northern Cardinal, a commonly found robot at UCI, was originally discovered by Team 26. Equipped with dual motors, the robot showcases sensory motor integration with its ability to quickly change its direction depending on stimuli. Additionally, the Cardinal has distance sensors and light sensors. Its ability to multitask with these sensors is critical to its survival. Utilizing a value system, the Cardinal has a varied diet, each source of food having differing effects on the bird's hunger and energy meters. The more frequent the robot consumes a given food source, the faster it will learn to consume it. This learning is remembered by the bird over time. The bird has to weigh the trade off of reward versus punishment as it considers each food option. Eating insects, for example, offers the most hunger but comes at a high energy cost as it chases the insect down. If the bird wants to survive, it will have to avoid many wild predators. Using its distance sensors, it can avoid the fearsome Cerberus. After avoiding the danger, the bird takes a moment to lay low. Such a marvelous maneuver by our cardinal. Here avoids another predator, a black cat. Beautifully done once again. As the bird hops around on the ground in search of food, it needs to avoid king snakes or milk snakes. Through degeneracy, the robot avoids snakes using its light sensors. Doing so does take quite a bit of energy, as the bird uses 60 energy to avoid the danger. Here, we see that our dear little bird ran out of energy. When it does so, it enters the tired state, leaving itself vulnerable to predators. Subsumption architecture is used here as the tired state subsums several other states. When the cardinal begins a day, its movements become sporadic and rushed as it stresses to find food. It turns more rapidly in this state and is less likely to pause. It's not until it reaches the threshold of 100 hunger that it calms down and goes at a more leisurely pace. This state is meant to mimic the hopping that cardinals often engage in. What a beautiful sight to see. In its natural environment, the robot will walk around on the floor and search for food, while minding predators in the background. Embodiment is what allows it to navigate in its environment while keeping track of stimuli it's looking for. When the bird reaches 200 hunger, a new day begins. It must once again search for food. We at UCI can time the robot to see if it truly learns to consume food faster and to test its proficiency at avoiding predators. This robot is seen as an initial step towards making a fully robotic cardinal, capable of gathering visual information for researchers.